Good morning, students. In today's lecture, we are having a discussion on some another chemical properties of phenol. In that, first we are going to discuss about Riemann-Tiemann reaction. Okay, let's see what happens in Riemann-Tiemann reaction. Phenol on reaction with chloroform in aqueous NaOH, that is sodium hydroxide. Phenol on reaction with chloroform in aqueous sodium hydroxide first forms an intermediate first forms an intermediate. Okay, this is your intermediate. Okay. In the first state, we are obtaining intermediate which on further acid hydrolysis forms salicylaldehyde. What is salicylaldehyde? To ortho position CHO, that is aldehyde group is present. Okay, so once again, phenol on reaction with chloroform in aqueous sodium hydroxide first forms an intermediate which on further acid hydrolysis it forms salicylaldehyde. This reaction is called as Riemann-Tiemann reaction. Okay, that's all about Riemann-Tiemann reaction. After Riemann-Tiemann reaction, next reaction is Kolbe reaction. Let's see what happens in Kolbe reaction. In Kolbe reaction, try to identify this structure. This structure already we discussed in methods of preparation of phenol. To benzene ring ONA, that is alkoxide group, sodium alkoxide group is attached. So its name is sodium phenoxide, right? What's this? Sodium phenoxide. When carbon dioxide gas is passed through sodium phenoxide at about 398 Kelvin under 6 atmospheric pressure, first it forms sodium salicylate. What? Sodium salicylate. So this is your sodium salicylate. Carbon dioxide gas when passed through sodium phenoxide at about 398 Kelvin under 6 atmospheric pressure, first it forms sodium salicylate which on further acid hydrolysis which on further acid hydrolysis gets converted into salicylic acid. To ortho position, COOH group is attached. Carboxylic group is attached to aromatic ring. So it represents your salicylic acid. Salicylic acid. This reaction is called as Kolbe's reaction. Okay. Sodium phenoxide on reaction with carbon dioxide gas at about 398 Kelvin under 6 atmospheric pressure first forms sodium salicylate, which on further acid hydrolysis gets converted into salicylic acid. This is called as Kolbe's reaction. Okay. After this, next chemical property shown by phenol is oxidation of phenol. Oxidation of phenol. Now see what happens in oxidation of phenol. Okay. Phenol on oxidation with chromic anhydride. What? Chromic anhydride or sodium dichromate in sulfuric acid. These are oxidizing agent, either chromic anhydride or sodium dichromate in sulfuric acid. Phenol when heated with chromic anhydride or sodium dichromate in sulfuric acid gets oxidized into diketonic group. Ketonic group is C double bond O. Here C double bond O, C double bond O. So this diketonic compound, its name is, आता position बघा, फर्स्ट हा कन्सिडर केला तर ही पॅरा पोझिशन येते. सो इट इज पॅराबेन्झोक्विनॉन. व्हॉट? पॅराबेन्झोक्विनॉन. ओके. सो phenol on oxidation with chromic anhydride or sodium dichromate in sulfuric acid gives पॅराबेन्झोक्विनॉन. याचं आयुपीसी नाव काय बनणार तुम्ही? पी च्या जागी फक्त काय नंबर 4 डॅश बेन्झोक्विनॉन. ओके. आफ्टर दॅट नेक्स्ट रिएक्शन शोन बाय phenol is catalytic hydrogenation. Hydrogenation म्हणजे काय? Addition of hydrogen molecule. Let's see what happens on hydrogenation of phenol. This is your phenol. Hydrogen gas when passed through phenol in presence of nickel as catalyst at about 433 Kelvin, it undergoes hydrogenation. That means this hydrogen molecule gets added into phenol. It involves breaking of alternate double bond present in phenol. Guess its name. See, hexagonal ring with single bond. म्हणजे काय होणार तुमचा? सायक्लोहेक्सेन. ओके. आता सायक्लोहेक्सेनला काय अटॅच आहे? OH म्हणजे हायड्रॉक्सी ग्रुप ॲलिफॅटिक किंवा सायक्लिक कार्बन चेनला जर अटॅच असेल तर त्या कंपाऊंडला काय म्हणतो? शिकलोय बघा याच्या आधीचं कंपाऊंड काय शिकलो आपण? अल्कोहोल. मग सायक्लोहेक्सेन ई काढून OL लावा, मग याचं नाव काय होईल? सायक्लोहेक्झॅनॉन. Okay. Phenol on reaction with hydrogen in presence of nickel catalyst at about 433 Kelvin undergoes hydrogenation to form cyclohexanol. A reaction takes place in presence of nickel catalyst. So this is also called as catalytic hydrogenation. What? Catalytic hydrogenation. Okay. After that, last chemical property of phenol is reduction. Let's see what happens in reduction. 11th ला झाली आहे बघा रिएक्शन. Phenol on reaction with zinc dust gives, identify the structure. What's this? Hexagonal ring. Circle का indicate करतो. Alternate double bonds are present there. So what's this? This is your benzene. Okay. So phenol when heated with zinc dust undergoes reduction reaction and gets converted into benzene. Okay. That's all about the chemical properties shown by phenol. Once again a revision of today's lecture. First, in today's lecture, what we discuss? Riemann-Tiemann reaction. Phenol on reaction with chloroform in aqueous sodium hydroxide first forms intermediate, which on further acid hydrolysis gets converted into salicyl aldehyde. This is called as Riemann-Tiemann reaction. Then next, Kolbe reaction. In Kolbe reaction, carbon dioxide gas when passed through sodium phenoxide at 398 Kelvin under 6 atmospheric pressure first gets converted into sodium salicylate. COONA, that is sodium salicylate, which on further acid hydrolysis gets converted into salicylic acid. Carboxylic group is attached to aromatic ring. The compound is salicylic acid. After that, we discussed what happens in oxidation of phenol. So, phenol on oxidation with chromic anhydride or sodium dichromate sulfuric acid gets converted into parabenzoquinone. Right? After that, what we discussed? Catalytic hydrogenation. Hydrogen molecule gets added to phenol. So, hydrogen gas when passed through phenol in presence of nickel as catalyst at 433 Kelvin gives cyclohexanol. And next chemical property that we discussed in today's lecture is reduction of phenol. Phenol on heating with zinc dust undergoes reduction and gets converted into benzene. Oxygen is removed from the phenol, goes to zinc, giving you ZnO, that means zinc oxide. Clear? That's all about the chemical properties of phenol.